Okay, now do we get to see the demos? Oh wait, hi! Welcome to Talk Chat Show Thing, Episode 3, with your hosts eleVR, Vi Hart, Emily Eifler, and Andrea Hawksley. Very special guest, David Smith, is going to show us the new Wearality prototypes we haven't seen yet, and we're very excited.
So if you guys haven't heard of Wearality, it's this new demo that we're going to see, and we're very excited because there's been a lot of talk about field of view, and we have never seen something with quite as much view on the inside as this, so we're excited to show it to you.
And the lenses.
The lenses are so cool.
Tiny lenses with that narrow sweet spot. But, okay.
Cool. So, a couple things. First of all, that you can see over there, this is our current prototype. It's for iPads. This one's not working yet because I haven't gotten any software on this. I just really got this a day or two ago, but I think you'll find it's quite nice.
Can we like show these lenses up to?
Yeah. Go ahead.
Like, see how much lens there is. Can you tell us about these lenses?
Yeah, it's a double Fresnel lens. It actually wraps around your eye. It's a curved Fresnel. Both of them are. And so each eye has two Fresnels, and it's like a double convergence. And what's nice about it is the lens is so close to your eye, you don't see the rings that you can see when they're further away.
Right.
But when it gets very, very close, it actually works out really, really well. In fact, one of the things I like to do, you can even do this with a camera, is just run one of these. Let's turn that on. Okay.
I love that it's orange.
I know.
Me too.
I'm going to show a little slideshow thing here. Here we go. And so you can see what's going on with the tablet. It's an equirectangular image that's running there. And then just slide this in. And you should be able to see that if I look at real close, you can kind of get a sense what that looks like. Of course, I can't tell what the guys at home see, but when I do this with my cameras, it actually works out really nicely. So take a look at that.
I'm like right in the stitching line. I'm going to be over here now. Okay.
So what kind of projection do you have to use to get it to look not distorted through the lenses?
It's almost a pure spherical transform. Mm-hmm. What I did was I wrote a vertex shader that's a true spherical transform, and the problem with traditional projection matrices, it's kind of a hack. Mm-hmm. You know, it was designed to fit in that little space, and it works okay, but it's not, as you know, very good for a wider field of view. I wanted a single pass transform with that, and so what I did is I fixed the projection matrix to actually do a true spherical transform when it does the projection, and that works out almost exactly right for those lenses. It is really quite nice. That's why it's pretty close. So you can see just a slight distortion still on the edges, because I don't think the lenses are perfectly spherical, right. But it's very, very close, and I think I'll be able to fix that too. And we're actually going to get a perfect transform next stage. We're going to just model it a lot better, but right now it's pretty good, I think. It should have been pretty good.
Yeah, it seems pretty good.
Seems pretty good.
So instead of having to do all the work in the software, you can just have lenses that...
Yeah.
Which is nice. I know for Android, what player we wrote, the Android version just does the spherical transform and doesn't try to do any kind of fancy barrel projection, because there's so many different things that you can stick a device into that I don't know what you're using it in.
Right.
So that really ends up being the best guess for a random arbitrary device.
Yeah, at some point, I think everybody's going to have their lens models available, and it'll just sort of be a plug-in to it. And certainly, the WebVR guys are looking at that kind of approach.
But for the Android thing, especially something like this, where the Android device is not necessarily talking to the headset directly.
That's right.
So, and it doesn't know what lens is, how far apart your eyes are, and maybe you move them really ridiculously far apart for some reason.
Yeah, try hyper stereo.
So is your plan to do is just to do the headset and not the like the tablet hardware, because I guess one of the things that these things suffer from is like that the tablets are sort of slow in the motion is a little slow.
A lot of it has nothing to do with the sensors themselves. It's simply the software stack they're sitting on. So there's no reason we shouldn't be able to get 60 hertz update rates, or better actually, with a tablet. There's just a good example is with WebGL, the web browser on there. It's hard coded to a 20 hertz update rate, and the reason it's done that way is because that's the way Apple does it, but there's no good reason for it. There are some concerns about power usage if you go higher than that. Not clear to me that's a huge strain, but in any case, I think we're going to see a way of getting. I mean, it's pretty simple to update. Get that to go at a much higher rate for the sensors.
Mm-hmm.
And then with WebGL, obviously there's a lot of additional rendering going on there, and if you're filling the entire screen, there's no reason to do that. So I suspect that we'll also see kind of later versions of web browsers that will kind of do a simple single pass with like a time warp distortion.
Mm-hmm.
So that's pretty clear that's going to happen, and it's going to happen next 6 months to a year.
Yeah.
So what do you feel like is your biggest challenge right now with getting this from, like, this is already like a really big update since when we saw it last.
Yeah.
So like, what are you guys working on currently to improve your?
This one we love, actually. We think this was designed for iPads, and we like the fit, and we like the finish. One of the questions we have is, this is a binocular system, and it's really easy to get into it, really easy to share like we're doing here. We've got some people would like to have straps for these kinds of devices, and our first pass, I mean, we're going to use this as our developer units, and we'll probably be sending them out over the next couple months for people to start creating content with it using these lenses as the target. So we expect that this is what people have in the very short term. Probably the actual devices, we're looking at probably a hybrid strap, not strap. Make it one of the things I find is when I'm demoing it, the right thing to do is just put it up to your head and look around, and that's great. The strap is really in the way of that, so I'd like to figure out a way to sort of have it two modes, because they're both they both have their usage, both have their value. If you're watching a movie, for example, it's you really want it strapped on because it's just inconvenient. Or if you're playing a game, so that's one of the other things that we like about this guy. Is what the other thing we're looking at little devices to control it here, or it may be a little micro joystick that we built that will just be able to plug right onto it. So you'll still be able to have full control with this. Alternatively, with strap, then you can use almost any Bluetooth device, including some of the devices we're building. But yeah, we like this guy. It's nicely made, and it has a nice feel. And really, we wanted something that even little kids could hold on to nicely. So this worked out well.
So this is built for something iPad mini sized?
This is an iPad mini size, and
there is an iPad mini.
and this was designed explicitly for the iPad mini. Just slides in there like that, and so
will you be just only having this iPad mini size, and you're not?
No, we're actually building some of those. Next, this is so Androids are a little bit easier for us to work with right now.
Yeah.
Particularly on the WebGL side. I mean, Apple's done a really good job with WebGL, but there's still some things that work on the Android side that don't work on the iPad side.
Yeah, I know I was frustrated with Apple's decision to make all the videos pop up in front rather than letting you actually have them hidden behind so you can see the WebGL transform on your video.
Yeah, I'm hoping that's a bug.
No, that's actually no. I think that's actually their design, is that all video plays independently in their player because they think it's a more efficient way to play video.
Yeah.
So they always just pop up a video in your player.
That's very frustrating because I think we do need to see.
Yeah, it seems to not be a bug. It actually seems to be how they're doing it, and I hope they fix it. Like, I tried a couple things and I looked into it, and I was like, this is not something I can do anything with, because that was very disappointing to me, because when iOS 8 app came out, I was very excited about potentially being able to run my WebGL stuff on it.
Yeah, I think video is obviously going to be one of the key killer apps, especially for the lower end devices like this, because it is transporting when you have these beautiful photo bubbles that like the one you're making right now. It's very easy to do, and if you have to build a player every time, it really limits access. And it's so nice just to take advantage of the web. I really think WebGL is the real future of these platforms, or the web. I mean, these are web devices. There's no question to me.
Yeah, and we obviously agree.
So it's pretty exciting to see. It is great to see Apple's embracing WebGL now.
Yeah, it took
I
a while.
grab the iPad because I want to feel the weight of it and see how it slots in. I can't help it.
There's an iPad
There's
right
one right
there.
here.
There's one right here?
Yeah.
Oh,
you just did it.
In and out.
I missed that because it wasn't like sleek and white looking like I expect iPads to be. This is an iPad?
Yeah.
I know technology. I don't know my iDevices. Ooh, it's got sound.
It's like a little virtual IMAX.
Yeah.
That's a cool underwater scene, and so the fish really pop out because it's a true stereo image.
I want to see, I want to imagine I'm like watching a movie and I just want to stick this on my face. Oh, I want to slide it so it's up instead of forward. Oh, that's fun. It is stereo. Look at all fishes.
Fishes?
Yep.
Yeah, it's two screens, one in front of you, one in back. So it's like it's a bit bigger than an IMAX theater screen. I wanted to make it see how wide I could get it and still make it kind of comfortable and still have a good 3D experience. And I think that worked out pretty well. I mean, you still have to move your head around to look at everything that's in there, just like you do in IMAX theater. So IMAX has got between 65 and 110 degree field of view depending where you sit in the theater, and that guy's obviously a bit wider. It's more like about 140 or so, 150.
That's really great. I think being able to generate something like that where there's a base that's rectangular in the background, and then you could actually have this fish swim just slightly off of the screen and then back would be really great.
That's pretty funny. You could do that. That'd be very interesting.
Yeah.
That's a cool hack.
Even if it, even if it was just a way to it was just a filter that you put over old 3D movies that you only ever saw in theaters that you could now watch in a VR headset, and you could just add a little bit of CGI to make things just slightly project out of the screen.
It's sort of like when IMAX, the intro used to be, they show you this little video thing playing at the center, and then they zoom in, and all of a sudden you're this huge screen. So it was now we start with a huge screen, and we just let the fish go off the side.
Yes.
What's going on? That'd be awesome. That'd be fun.
Yeah,
it's
just
all interesting.
Have some little fish bots dynamically. Yeah, I think you can get much closer to the cameras and it'll work.
You might be looking at the side of it though.
Yeah, I think this was not the side because I saw color, but I'm not 100% certain. It's a little hard to see without.
And
fairly close.
How does this new one address I guess the small problems for me with this headset is that there's a little black arc on the sides and the bottom from the transform.
This is since the iPad's a little bit bigger, it's not as noticeable, but it's still there. Part of it is those lenses were designed for a bigger field of view than we can get with the tablets, and it's just.
So you just need bigger tablets.
A wider tablet would be nice, actually. That would make a bit of a difference. The ones we use in the lab, we actually have two HD screens, one for each eye. They're basically phone screens, and that's optimal. That's what that was designed for. The problem with that one is a bit expensive. Because you have to have the screens, you have to have all the electronics. We thought it'd be really neat to get a low-cost device like this to be able to, get people to start playing with, a really immersive experience like that. Because the lenses are a pretty big differentiator, as you can tell. I mean, they're kind of off the scale of what's possible today.
Right, and this seems like a lot of the work in this is going into the lens. Like a lot of the design goes into the lens, and then like this holder can be adapted to tablet sizes as they increase.
That's right. Yeah, right. We make bigger, smaller. And we're looking at another design. Where's that? Did I bring that box? So let me get this. I didn't put it through though.
We're missing a box somewhere?
Oh no, it's right here. Did another design that's works with my phone.
Oh, nice.
That's
excellent.
early prototype.
I love looking at early prototypes. They're so. I mean, there's like layers of lenses.
Yeah,
So
it's
yeah,
the same.
You said 2 Fresnel lenses.
2 Fresnels on each side.
So this is what the lenses look like in profile.
And yeah, I really like that guy. And let me see. Actually, this one works great with cardboard. Let me see if I can find that.
Are you guys the only ones doing this like double lens idea? Because I feel like most of the headsets
probably. I
are
hope
just
so,
using
because
like.
we got a patent on it.
Yeah, I feel like you guys have the coolest lens technology of anyone who is out there.
Yeah, well, this came out of Lockheed Martin, where I'm senior fellow and chief innovation officer, and so here's the cardboard app running Google Earth,
Okay, so it's the Google Earth cardboard demo.
and this just kind of works nicely. It's obviously nowhere near as wide this one is, but it's still pretty nice. You can look around.
Some of this seems really quiet with the noise.
Oh yeah,
Turned off.
the movie, or it ended.
Or we turned on the sound. So.
Yeah, I like the. This is a great solution to me because in Google Cardboard the lens is so small and it's not perfectly aligned with my eye that it's impossible for me to see 3D in Google Cardboard. But
there's a couple nice properties. One in particular that's great about these lenses is the exit pupil is the largest in the world, so it's extraordinarily forgiving depending where your pupil is, your IPD is. Doesn't kind of matter, at least on the hardware side. So we can do fixed lenses without having to change the lenses out. It's just very, very happy to do that. You might have to change the virtual image, the image on the screen left and right, it's expanded, but you don't have to change the lenses.
That's a much easier solution than having to do adjustable lenses.
And it's cheaper, and but the nicest thing, though, is you notice it's also in focus everywhere, like I said before. So you look up there, it's in focus. And one of the key things is, especially in usability, when you're using a narrower field of view, it's a pretty uncomfortable experience. Partially because you're having to track a lot. To find things, find targets, and targets, I mean just things to look at. Good example is, that's the problem we have with night vision. You notice those guys, you see the films of people with night vision goggles, they're looking through a soda straw and they're having to scan around a lot to be able to figure out what's going on around them. Even then, they often lose sight of each other, and of course for them it's really important because the bad guys are always out on the sides. For this, it's really important because you're like, I can see where I want to go with my head. That's the important thing of that peripheral information. So when I turn my head, it's right there. You lock on. It's a really easy motion, and it's a very comfortable motion. Where if you're looking at a narrower field of view, like most of those things out there now, you have to do this a lot more. So it's I don't think it's just inconvenient. I think it's part of the reason people get a little ill is because of that need to track left and right.
It's not just the tracking left and right that makes the smaller lenses. It's that because like on cardboard they're not really adjustable. If it doesn't match up and it's got such a small range, then people will get sick just from that before they've even really started looking, because they're just like, my eyes don't know how to process this. And specifically with Google Cardboard, I've seen a lot of people have that problem because, I mean, it was a cheap cardboard box demo, and it
was spectacular.
And, it's spectacular, and it's really spectacular. But I think if you're expecting it to like be perfect, obviously it's not, and it shows a little bit on things like that, where it tends to make people more sick than most other headsets that you might want to try.
That's right.
And you can't adjust the things, and they're like really assume your eyes are about this far apart, and if your eyes are the right distance apart, and then it will look reasonably good, and if they're slightly off, the more off they are from what their expectation is, the more likely you are to get sick.
On the other hand, I think they're doing a great service, first of all, educating people about these things, and the other side is doing some really neat software platforms
I think
us.
Google is more about the software, and software and getting it out there is something that, like, hey, you don't need to spend, hundreds of dollars on, the latest Oculus or whatever Project Morpheus thing to be able to do VR. You can do it with the device that you're carrying around in your pocket all the time. And I think that was something a lot of people had not realized, and it's the thing that's going to make VR accessible.
That's right. I think that's, especially today, we're kind of in an education phase, right? It's like illustrate what the technologies are capable of doing, and the lower price we can make this, the lower the entry bar for people to start playing with it, the better, because we really want to see people start experimenting with what the capabilities are. It's sort of like the whole idea of the home computer a long time ago was, hey, let's get these technologies into people's hands and let them liberate it. So having very inexpensive little CPU-based computers, even though from a business perspective it didn't make any sense, having somebody out there, probably some 19-year-old kid's going to see these devices and say, I know what that's for. Because the reality is, and we kind of know about games, that's going to be pretty neat. The reality is the true killer apps for this new platform hasn't been invented yet. And that was demonstrated. I mean, when the Apple II came out, I guaranteed Steve Jobs did not know what it was for. He thought, here's a home computer. It's neat. But Dan Bricklin saw that and said, I know what that is. That's a spreadsheet engine. And so he built VisiCalc, and that what happened after that is Apple's sales tripled month over month. And that really was what defined Apple more than the Apple II, oddly enough. Same thing happened when the Macintosh came out. It's like, remember, it was neat, you could do Mac Paint, Mac Write, but what was it really for? And it turned out it was a desktop publishing engine. It allowed you to, be creative with content that what you see is what you get, was absolutely essential for that space. Happened again when the iPhone came out. Remember, Steve said, hey, you can make your own apps on the web, but Apple will make the real apps, and the developers said, no, that's not going to work. So the App Store had to be invented. And what is the iPhone? It's an app engine, right? I mean, and so the people who create these technologies often are the least clued in to what their real value is. Mm-hmm. I think we can always say games are going to happen. That's a nature of what we are as humans. So all those devices I just talked about have a lot of value on the game side. In fact, no successful platform exists that doesn't support games in some way. But games are not the killer app. They're not the things that are going to redefine the nature of our relationship with these devices in a fundamental way. And I think that's coming yet. Well, I think, first of all, I look at VR as a stepping stone, and even with that, a short one. VR is kind of a subset of what AR is, augmented reality. And because once you get a wide field of view lens on the augmented reality side, we can do everything you can do on the VR side. but you also have this ability to extend the real world in fundamentally interesting ways.
Mm-hmm.
So just for fun, I brought some of the lenses. This is one that's painted black, so you can see that a little easier. But this is an AR lens that we did that is basically the same field of view as this guy.
Mm-hmm.
So it's kind of crazy. That's it right there. You can see it close up. But the way it works is, this is an asymmetrical lens. I'll get into the main point of this, but this is an asymmetrical lens. So basically, if you have a display right about where your eyebrow is, it is in focus everywhere, just like just like the Fresnels are.
Mm-hmm.
So what happens then is this is up to your eye like that, and everywhere you can see how wide a field of view this guy is. So you'll actually have a kind of a Terminator screen that is, far wider than the existing VR headsets. This is probably about a year away before we'll actually have prototypes in people's hands. But that lens works right now. In fact, it's pretty spectacular. We're very, very excited about it.
And how are you making the lenses?
What special information can we know?
Yeah.
Actually, it's all patented, so I can tell you. The idea, the problem actually with an asymmetric lens like that is you can't use a traditional CAD package to make it. You can't use ZMax, which is the standard optics design tool. You have to. We had to write our own tool, mm-hmm. and it works this way. It's first of all, one of the challenges is if I took a spherical lens, traditional spherical lens, and put it up to my eye straight on. I showed you guys this last time, I think. You see your eye perfectly. It's great. But as soon as you tilt it down and you put a little display here, all of a sudden the focal length changes across the surface. Mm-hmm. So some of that display is in focus, some of it's not. So what you need to be able to do is modify that surface so that the focal length changes across the surface. The problem is, if you think of it, if you divide that surface up into what I call oxels, optical elements, then you heard here first, evidently. What happens is the oxels overlap, mm-hmm. right? They're little spherical mirrors, and they just sort of, this one, if I make this one great, this one gets screwed up. If I make this one great, this one gets screwed up. So you need to figure out how to minimize the error to the user so that everybody plays nice. And so what we do is we break this up into oxels, and we kind of compute an optimal surface for that given point. Then we divide that by 1,000, and we iterate literally about 50 million times. It takes about a week to compute this. And what we get then is a point cloud where it's in focus everywhere. Mm-hmm. And so what's nice about it too is, like, you think about it, well, it's not perfect. Well, it's better than 2020. And that's all we need to do. Humans are not very good optical instruments, basically.
You're not building an HMD for a hawk. It's fine.
That's right. So that's how we build that. That's how we design. So then we get a point cloud. We model that. We take the point cloud, convert it to a NURB surface, and we either send it to a 3D printer where right now we're making a mold from that, and then we do a vacuum form on top of mm-hmm. it, or we send it directly to the manufacturing to make a lens like this. And what's really cool is today, between 3D printing and kind of the rapid prototyping that can be done, we can actually iterate pretty fast on the optics. Today we can actually create a new lens almost on a daily basis, and then this takes about a week to get done. And then this one is basically the perfect representation of the.
You can make a lens faster than I can make a video.
Almost, yeah. It's crazy. Well, that's necessary because it's such a complex thing. Mm-hmm. When we first did it, when we first started this, it took about a month turnaround to actually, from the time we had the lens designed to we actually would have something in our hands. And that was, and we actually we knew it was going to take a month. We never actually did that because it was such a problem mm-hmm. to iterate. And so we figured out, hey, we can actually 3D print them. So our first cut of these was literally printing these in a material that was clear. You could kind of see the layers, but we sanded it, and it actually worked out that it was good enough for us to determine whether the solution was okay.
Mm-hmm.
And so we did that quite a while, and then we switched over to the vacuum form, because the vacuum form is kind of neat because it literally does its own kind of spline surface over that surface over that area. So that worked out great. And then we did these. So that's why we can do it so quickly now. So the reason, though, I think, when I look at augmented reality, this goes back to actually more Doug Engelbart than anybody. It had this concept of augmented teams, augmenting the human to be a lot more capable and allow us to communicate ideas and have relationships that sort of transcend what we can do without the computer as part of it. Some of the projects that we've worked on, Alan Kay and I, and David Reed and Andreas Robb worked on a project called the Croquet Project, which is a true collaborative 3D system. The idea of that was to allow people to do very deep collaborative work, even to the point where you could do some programming. But the real goal of this was to have the computer as a full participant in a conversation where we're talking, computer's listening to us, and generates a simulation based upon that conversation that all of us are able to engage with and interact with. And so that means that our conversation is expanded. The bandwidth of the information we're able to convey and the idea space that we're able to explore, it becomes very, very large.
Mm-hmm.
So what I was after, what we've been after, was this idea of the computer having that. We did the software side. In fact, we did another iteration called the Virtual World Framework, which is open source as well. It's virtual.wf if you want to check it out. True collaborative platform, WebGL, WebSockets, WebRTC. You can go there right now and start playing with it. But I see that as the operating system for this wearable device. So what we're really doing is not only extending our ability to communicate and collaborate, but we're also turning the internet inside out, right? So we're now wearing the internet. So I see this AR device as it's certainly, these are going to be the next computers, but more so, it's a communication device like we've never seen before. Mm-hmm. I think that's the really interesting thing. It's a very intimate computer. It's going to be a computer you put on in the morning. It's sort of like you put your cell phone in your pocket when you wake up and go to work. And in a sense, you've got the internet in your pocket, a little window into that world. But what would happen if you had that available anytime and almost available just by thinking about it? So that's what this would allow us to do. And so when we look at where the browser is going and where VR is today, we see this convergence of all these technologies. So a pure VR, like I said, is sort of a stepping stone to what's really going to happen, which is a true augmented reality experience where the web is at the center, enabling us to explore these ideas together. So that's
it's like where the internet and mobile and wearable computing and personal computing is all sort of like coming to this.
That's right.
Confluence of the thing that you use it for everything and you have it on you all the time, and it becomes less separate from the real world, and computing becomes like literally more ubiquitous because it's in front of your face all the time.
That's right. We're already seeing that with the phone. The smartphones, I don't know why we still call them phones, because no one uses them.
When is the last time you called someone with your phone?
That's right. So what you're going to see is exactly that. It's an expansion of our capabilities. I wrote a paper 7 years ago called "You Will Be Superman," and the idea was, Superman could see through walls. Superman could, had all these superpowers, jump up in the air. So I showed you Google Earth running on this thing, so you could literally jump up into the air. What's really cool to me is apps are like these little mini superpowers. You get a new app, and all of a sudden you can do something you could never do before, that you could never even imagine. And it's just like this overlay information and capability that now exists that didn't exist a few minutes ago. So I sort of see that's the most exciting part of all this, and that's really the goal, the end game of what we're doing. These technologies, we think field of view really matters. Software infrastructure really matters. The web is the center of that world, and I think we're going to see it over the next few months even. We're going to see that the web becomes a far more capable platform for these kinds of devices. I think you may still want to go to a native platform for doing games of certain sorts, but when I look at what the potential killer app is, it's going to be on the website. It's not going to be on the app side.
I'm really excited to see like one thing that I think I love so much about apps on my phone is not what every individual app can do, but like how I can recombine them into making something new. Like I have put a lot of work into like learning how to making different GIFs or images, like using different image software on my phone to like recombine their efforts. And I'm just really excited there's a lot of individual different kinds of things that are happening in VR right now, like video and games and web, but I'm much more excited to see like, well, when you have it on you all the time, the combinatorics of all those things is going to be much more interesting to me than the current things that everyone is making. And
I think that's the other nice thing about the web. When you think about it, it's the largest open source project in the history of mankind, in that every web page has the source available, right? And and that's how I learned how to program the web, is I looked at other people's stuff. He did some really cool thing there. How did you do that? And you can look at it and then take that and plug it into your code to extend your capabilities.
The advent of minification of like JavaScript and things, which makes everything run much faster, also means that your ability to see how did they get that cool effect has sort of gone down drastically because it's not readable anymore.
Well, yeah, that's too bad. Although we have tools that can put it back. But yeah, it's an interesting challenge. I don't, anybody who's reasonable programming go through that and say, okay, that's what he's doing. But it's still there, and I still see that as the magical thing. Is the web is still so incredibly open, so accessible. And there's so many ways to address it, and certainly what we'll start seeing too is ability to start combining those capabilities. I sort of see this device as a layered thing. We're going to have, it's like, first of all, you're going to have this thing that it encompasses your entire vision. These little micro web pieces of information everywhere. There might be even a web page that's floating. It might still have a 2D web page inside this incredible 3D space.
But maybe it'll have that overlap that we were talking about before with the IMAX thing, where
that's right.
Where it'll have some sort of 3D add-on to your 2D webpage in VR.
Yeah. So the fish swims out of the IMAX screen and goes over to the side. I think that's very cool. So I think it's an extraordinarily exciting time, and I really think we're about to liberate the web in a way that's never been done before. And so that's why I think the web's really, and we don't think of it that way because it's not quite where it needs to be. A lot of that, it's artificial barriers have been put up, like the 20 hertz update rate on the sensors, or not being able to play video inside of the 3D world that Apple's done right now. I think that's, like I said, I think of that as a bug, not a feature.
I think that right now, at least, they are thinking of it as a feature.
Well, thank you so much for being on our show. It was
My
so
pleasure.
nice to have you.
Yeah, thanks for sharing all your cool stuff.
And when you guys are
so
launching it, we would love to see all your future demos.
Yes.
So is there somewhere we can send people to get more information? Is Wearality.com a thing yet?
Wearality.com is close, very close.
Okay.
By the time we're done with this, if like in a week, by the time we're done.
I'll make sure we're ready.
Okay. Then Wearality.com.